welcome back to Josh Does Math. In this video we're going to be doing a calculus problem that involves taking the derivative of a function. And we're not going to be using the power rule for derivatives. Instead we're going to be using the limit definition for derivatives. And that looks like this. F prime of x is equal to the limit as h goes to 0 on f of x plus h minus f of x all over h. So we're going to be using this definition of a derivative to find the derivative of the function. So I'm just going to plug in some things here to the definition of the derivative. I won't plug in that first term in the numerator yet. I'll start with the second term because it's easier. So for that second term, I'm just plugging in the functions. That's ax squared plus bx plus c. This is going to be all over h. So now for that first term, I'm still plugging in the function, except for every x in the function, I'm plugging in x plus h. So this is going to look like a x plus h squared plus b x plus h plus c. And now if I were to just try to solve this limit the way you'd solve any limit initially, I'm going to put in 0 for every h, and you can see that's going to result in 0 over 0, which is an indeterminate form. So we need to do something to the numerator to simplify it down so that we don't get 0 over 0, because that doesn't tell you anything useful about what this limit evaluates to. So we'll simplify that numerator. First I'm going to use FOIL here for this x plus h squared term, so that becomes x squared plus 2xh plus h squared. Then I'm going to distribute the b for this next term, so that becomes bx plus bh plus c, and I'm going to distribute this negative sign to every term in this last polynomial here. So that's going to become negative ax squared minus bx minus c. And you can see there's going to be some cancellations in the numerator already. We haven't even distributed a into this polynomial here, but you can see there are some cancellations already. So I'll cancel some stuff before I rewrite it, such as positive c and negative c, positive bx and minus bx, those cancel. And that looks like everything at the moment. So now I'll rewrite it out, and I'll distribute the a. So this becomes ax squared plus 2axh plus ah squared plus bh minus ax squared all over h. So at this point you can see there are some things that will cancel again. And those things that cancel are ax squared and minus ax squared. And that's everything that cancels. But as you can see, there's an h in every term in the numerator and an h in the denominator. So h just divides out of the whole thing. And we're left with 2ax plus ah plus b. Now, if you plug in 0 for h, you end up getting this, 2ax plus b, because this term becomes 0 whenever h is equal to 0. So we're left with 2ax plus b, and that is your derivative. So that's it for this problem. We solved for the derivative of the function just using the limit definition of the derivative.